So the first email you sent with your set one of problems that you were struggling with, those all revolve around a topic called the conics. I won't get into the history of this, but the conics, you were probably introduced to them a little bit in Algebra 1 and Algebra 2, and maybe a little bit of pre-calculus in high school, but not at the level of detail that these are covering. So probably the first conic that you're most familiar with is what's called a parabola, which is that U shape that you saw in Algebra 1 and Algebra 2. Uh, but the difference here being that instead of the U only opening up or down, these U's could also open left or right, which means they're not functions. Uh, so we deal with them as a group. I know, and I'm going into a little more detail than I saw showing up in your problem sets, but I showed these with inclusions of our vertices. So in both of these, the vertex is at HA. And it's because we took and shifted our x's right H and our y's up K. And here, our x's were right H and up K. And if the signs were opposite, that would move left or down. Then the P in both of these, P is what we call the focal length. This is the distance from focus to vertex. So I measure from my vertex to the focus, or vertex to directrix. And the directrix is a line, either vertical or horizontal, that plays a role in how we determine the points on this, because every point that we take is equidistant from the focus and the directrix. That's actually how we define what a parabola is, rather than going with the equation. If we define it graphically, it is the collection of all points that are equidistant from a point called the focus and a line called the directrix. But in case of our equations, what we're interested in is that value p. So kind of when we look at an equation for a parabola, the first thing we worry about is it opening up, down, left, or right? And then we can start orienting ourselves in, should my focus be to the left or to the right, or up and down from the vertex? Is my directrix then also left, right, up, or down from my vertex? So if we take a look, just say we make up a problem such as x squared equals 12y. Because the x is being squared, this means that it is opening up or down. And the way I determine whether it's up or down is positive means up, negative would mean down, so this opens up. My vertex, my x's have not been shifted, my y's have not been shifted, so my vertex is at 0, 0. So what I get is, if I do a little sketch, is this shape for my vertex is at 0, 0, which means that my focus is going to be up here, and my directrix will be down here and be a horizontal line. So to find the focus and the directrix, what I need is that value p, which for p is going to equal 12, which means p is 3. So that means if I move up 3 from my vertex, my focus will be at those coordinates. If I move down 3 from my vertex, then in the opposite direction from the focus, so from my vertex, instead of I went up to get to the focus because that has to be inside my U, my directrix is outside the U and in the opposite direction from the focus. So I go from the vertex down 3. And since it's a horizontal line, it's y equals, and moving down 3 gives me a value of negative 3. So there's my focus, and there's my directrix. Now, I saw a lot of the problems that you had in that first set do involve something that's called completing the square. In terms of what we were working with, this goes by several names in the forms of these equations. They will called things like vertex form, center form, focus form. Um, it depends kind of on the shape, what name they get. Whereas when written this way, this is called standard form. Now, just by looking at the standard form, I can get an idea of what shape I am dealing with. Because only one of my variables is squared, that makes it a parabola. If both were squared and I was adding them with the same coefficients in front of the squared terms, that would be a circle. If both were squared and I was adding them with different coefficients for the squared terms, that would be an ellipse. And if both were squared and I was subtracting them, regardless of coefficients, that would be a hyperbola. So since one is squared, this is a parabola. Since the y is squared, I actually know that it opens left and right rather than up and down. So what I want to do is everything involving the y's is fine where it is. I'm going to move the x and the 9 to the other side. And I'm going to leave some space for adding things in there. -9. And what we do is I need to figure out what am I going to add right here to make this a perfect squared trinomial. And realize that whatever I add over here has to go over here. So the way I figure that out is I take the b value from our ABC when we do quadratic formula. The b value goes with the variable raised to the first power. And I want to take that and divide it by 2 and then square it. So that's 25/4. And that's what I'm adding on to make this a perfect square. But anything I do on one side, I have to on the other side of the equation, I'm also adding 5/4 so that my equation stays balanced and I'm able to keep it as equals. Well, that then means that this left side is a perfect square. It's going to be y plus or minus something squared. And then I have x, and combining like terms here, that's like 11/4. Now, quick shortcut. What's going to go into this spot right here is actually that b divided by 2 part. That's to save us some time there. So -5/2. So what I can see is this is a parabola. It's either opening left or right. The squared part is a positive, so it is opening to the right. And then if I move my 11/4 over, so it's actually in a standard form that I'm more comfortable with. So x would equal to y minus 5x squared plus 11/4. My vertex is at 11/4, 5/2. And then for my p-value, 4p has to equal that value in front of the squared part, which is 1. So p is 1/4, which means if I do a quick sketch, if this is where my parabola is, my focus has to be here, my directrix is here. So my directrix is a vertical line. So my focus is going to be that 1/4 to the right, which means I'm adding it to the 11/4. So my focus would now be at 3 5/2. And my directrix, I'm going to move 1/4 to the left, so I'm subtracting 1/4 is going to be at 5/2. Oops, it's a line. I know better than that. Vertical line is that, so I have x equals, and then the value will 5/2 because 1/4 minus 1/4 is 10/4, which simplifies to 5/2.